There we go. If you take a look at this circuit, this is on Edmodo. You'll find this picture. You'll find the video that shows you how to do this. What I want you to kind of get from this right now is, if you could, try, see if you can find the resistance of the left side and find the resistance of the right side. Okay, and then find the total resistance. If you look at this picture here, we've got current coming out of the battery, and it's going to split up. It looks like these two are parallel to each other. Then that current comes back together, and it goes through this little series wire. Okay, and it's going to split up again to get to these resistors, which are parallel to each other. Okay, so that's kind of the picture here. Resistors on the left in parallel, resistors on the right in parallel. Together, they're connected in series. Could you take a minute to try out the math on that and see if you can get the total resistance left side, right side, and overall? Okay, I'll give you a minute or so to try that out. Okay, so at this point, I'm hoping you saw this would be 8 ohms of resistance, 1 over 12 plus 1 over 24. You take the reciprocal of that sum, you're gonna get 8. Hoping you took a look at this one and you saw that this should come out to 4 ohms of resistance. 1 over 5 plus 1 over 20 equals 1 over that total resistance. Okay, that should come out to be 4 when you take the reciprocal. So 8 should be in series with 4. Okay, so again, we're not going to go through this whole thing, but I at least wanted to do this so that we could see 8 and 4 in series. That should give you 12 ohms of resistance. And I want to be able to figure out how much current's coming out of the battery. So you've got 72 volts pushing charge through 12 ohms of resistance. We should get that total current, check my math, should be 6 amps coming out of the current, coming out of the battery. So now here's the thought process that I do want to mention to you. Here's a strategy that I think will be helpful going forward. I'm leaving the rest of this visual, or the rest of this circuit, to what I've already done for you on YouTube, basically, but you'll find the link on Edmodo. But what I do want to point out is, what I'm going to ask you to do today is consider this. If you've got 8 ohms of resistance on the left side, imagine we took those 2 resistors out of the circuit and replaced them with, replace them with a single resistor that was 8 ohms of resistance. Okay, so I know the circuit really looks like this, 2 parallel resistors, but let's imagine we replace them with an 8 ohm resistor. If we did that, you'd still have 8 ohms of resistance connected in series with 4 ohms of resistance. We get the same amount of current coming out of the battery. Okay, the reason why I'd have you do this is just so that we can maybe find what this voltage difference is from red to green. Okay, because here's the thought process also. If we can recall, all right, whatever current comes out of the battery, okay, is going to go this way. And instead of splitting up, we'd have to recognize that all of that current goes through this one single resistor. That's why we spent so much time on all the pages of this packet, because we've done something that looks just like this. All right, when you've got one resistor all by itself, all the current coming out of the battery will go through that one resistor. All right, it will split up here, of course. Okay, but we could do this strategy step just so we could see what the voltage difference is across here. Okay, so now the thought that I've got that follows up with that, we had mentioned that this is an 8 ohm resistance. And even in reality, even when it is 2 resistors connected in parallel together, they make 8 ohms of resistance. And we just said that the current going through this resistance should be 6 amps. So if that's the case, notice what we've got. We've got resistance, we've got current. We're all set up to solve for V equals I times R. Okay, so the next step I'd like to do here is just say, if we know that value, or if we know those pieces of information, we could then take our voltmeter and make connections here. Okay, that red-green connection is going to be 8 times 6. I'm pretty sure that's 48 volts. Okay. All right, so with that in mind now, we can also do this. We can say, well, let's suppose that we take, oops, my apologies. Let's suppose we take this picture out of here and make it look like the original picture that we had. Okay, now we can say you've got a 24 ohm resistor that's got 48 volts across it. You have a 12 ohm resistor with that same 48 volts across it. Now we can find some of the details. We can see how much current goes through this individual resistor, how much current goes through this individual resistor. Okay, so that's the strategy I'd like you to try today. Whether you've done this one online or not, or you saw that I had it posted or not, I think that's a strategy that should be pretty helpful here for us. Okay, so give me 1 second. Okay, so on this slide, what I've got here is I've got a picture of a circuit that should look very similar to the UTexas circuit for question number 1. All right, what I'd like you to try out here is either draw this out and color in the wires, or if you happen to have a printout of the UTexas problem set that's due this upcoming Sunday, assignment number 11, you could just, color right on top of that picture. All right, but for now, take a minute here. See if you could please draw and color in what the voltage colors would look like in all these wires. Okay, I'll try to pause here for just a second and let you do that for about a minute. I'm going to continue on here, and you can keep coloring this in if I didn't give you enough time there. But taking a look at this, here's my high voltage wire. It's going to stop right here. My low voltage wire should stop here. All right, this is going to have to be some in-between voltage. This will have to be some in-between voltage. When I colored those in, I kept those two in-between voltages different colors just because we don't know for sure if the voltage in this wire is the same as the voltage in this wire. That would depend on these two resistors and these two resistors. So we don't know for sure. So I just put it as 4 different colors for now. But now here's the benefit of doing this method. I can redraw this circuit. I did that last week with an example that helped you out with assignment number 10. Sometimes redrawing the circuit makes it a little bit more user-friendly, makes it so that we can better visualize the type of circuit we're dealing with here. It's a little bit tricky to visualize, having this big diamond in the middle. So my next click here, I'm hoping that was enough time for you to finish coloring in. Basically, this is what's given on UTexas. I can redraw it to look like this right in here. All right, this circuit is the same circuit as was given. Now, they look a little different, but they'll behave identically. All right, notice what we've got here. You've got a couple of resistors up top here that are connected red, green, blue. It's as though those are in series with each other. Okay, that kind of follows that series model when we've got 3 colors. Same thing down here, this red, orange, blue, those are in series with each other. If you look up here at the original picture from UTexas, from red through green to blue, those are in series up top. Same thing right underneath here. These are in series down here. All right, but now the other part to this is that you can still see the red-blue color difference here, red-blue color difference. It means that the top branch is parallel to the bottom branch. All right, so we are looking at a parallel circuit, but within that parallel circuit, there are some series resistors. All right, this is very similar to last week's assignment. Those of you who did last week's assignment, you should recognize this. And the whole idea here is if you know a red-blue color difference, that's the voltage of your battery. We know the voltage surrounding this combination. What you need to know is how much resistance is sandwiched in between this battery voltage. And then from there, we should be able to figure out how much current travels through that branch. Resistors in series should have a common current going through them. All right, again, very consistent with everything that we've said so far this entire unit, okay? If you need, you can keep going back and looking at the rules for circuits page that we filled out together back when we were still in school. All right, so try these out. See if you can get a solution for this one. I'm gonna leave this one as it is because it's real similar to last week. I'd like to spend a little more time on the one that's very new. There's one more question on UTexas where they take and close this switch. Okay, that's all this is a switch, and they can close it so that it now connects the top and the bottom wire here. So let me go on to my next picture. And again, either draw this and color it in yourself. I'll give you about a minute to do that. Or if you've got the printout, just color right on top of that printout. Okay, I hope that was enough time to at least get this drawn out. You can keep coloring it as I'm talking through this. But again, I mentioned just a moment ago that this is now one continuous conductor because we closed that switch. All switch does is it connects one metal to another metal. So if these are continuous conductors, they should all have the same voltage. This entire wire in here is a common voltage because it's a common wire. So here's what my coloring now looks like. And I could have chosen green. I could have chosen orange. You could choose any color you want. But the key here is that this entire thing is all one color now. So that gives us a model that you've got red, green, blue, we've got another series circuit here. Even though it doesn't look similar to the series circuits that we've done, this is a series circuit. All right. Before I show you what the redrawing would look like, notice this red-green color difference. That's in parallel with this red-green color difference. Again, the power of coloring in your wires is evident to me right here. So these are parallel to each other on the left side. Here you've got a green-blue color difference, green-blue color difference. These two are parallel to each other on the right side. And it looks to me like the left side is in series with the right side. What I'm trying to paint the picture of here, and I'll show you the visual in just a second, it should sound a lot like what I described in that opening start to this meeting. The circuit can be redrawn to look like this. All right, so that was the example I wanted to post this weekend for you to take a look at if you had time, you know. So if we now take a look at this circuit, we can recognize that you've got a pair of resistors on the left side that are parallel to each other, a pair of resistors on the right side that are parallel to each other, and the right and left side are in series with each other. So for this problem now, I'm going to ask you to take some time to redraw this. I know it takes a little bit of time here, but draw that out. And I'm going to give you some numbers for each of these resistors. I'm going to give you some numbers for the battery. And I'd like you to evaluate this circuit. So it's going to be real similar to what I've got posted already on Edmodo. But we'll do this one together, and you'll have that Edmodo one you can go through on your own when you have time if you still need another example. All right, so with this here, the numbers I want to give you, 20 ohm resistor, 5 ohm resistor, 4 ohms and 12 ohms, and a 14 volt battery. Okay, so while you're drawing that, I'll mention the questions that I'm going to ask for you to do to look up here. I'd like you to figure out the total resistance. I'm going to have you figure out the total current. That's kind of a good starting point, especially when we have a complex circuit. I ask you to figure out the red-green voltage difference, the green-blue voltage difference, and then we'll figure out the current going through each of the resistors in the entire circuit. Okay, so this is, again, just an evaluation of the whole circuit. It's basically what we've done over and over for several weeks now with having a little table off to the right-hand side of this where we're filling in all the voltages and currents. All right, let me change this up for just a second. Here's where I want to go. I'll have those numbers back on your screen here now. All right, I just wanted to show you with this PDF version that I've got what our goal is here. There are several ways you can do this. I've had some people using like a ratio method to figure out how much voltage you'd have across here and how much voltage across here. If you could please try this method, I'd like you to consider, if you know the total resistance of this left side, when you finally get to that step, consider if we replace those two resistors with a single resistor. And if we did that, here's the concept that we've been building up to. All the current that came out of the battery, what you're going to solve for in part B, all that current has to go through this one resistor sitting all by itself before it could split up. Okay. Again, I realize it's not a single resistor, but the purpose of that is, suppose it was a single resistor, we would know the resistance, and we know all the current going through here, and we can go back to our V equals IR equation. Okay, the voltage red green should equal the current times resistance going through this resistor. Okay, and once we know that red green voltage difference, now you can see that this has that voltage difference and this one has that voltage difference. From there, a couple of steps that you can identify. You could do the same model for this segment, which I'd like to show you later on after you've discussed it a little bit. But you could also do this. Now you know the voltage in the red wire is 14. Voltage in the blue wire is 0. We can figure out the voltage in the green wire because of the steps that we just accomplished, what we just figured out. Remember, the voltmeter is going to tell you a voltage difference. Okay, so you know this is a 14 volt wire. This number here can be figured out if we know the voltage difference across this set. So again, just trying to show you that there are consistencies with everything we've done up to this point. Okay. Okay, so here we've got our numbers back, and I've got our questions back here. The stuff that I'm hoping you were able to figure out, these two in parallel with each other should give you 4 ohms of resistance. These two in parallel with each other should give you 3 ohms of resistance. Together, they're in series. They should give you 7 total ohms of resistance for the entire circuit. Try to pick some user-friendly numbers. You've got a 14 volt battery, pushing charge through 7 ohms of current. Okay, voltage divided by resistance should give you a current of 2 amps. Okay, so now the red-green voltage difference that we're looking at here, we know this is a 4 ohm resistance on the left. Let's imagine that we replace those 2 resistors with a single 4 ohm resistance. And the discussion of 2 amps leaving the battery, all that current has to go through here. This is giving you a current times resistance that should tell you the red-green voltage difference. That looks like 8 volts. We can do the same thing. Well, for one thing, you could look at this, say 14-volt battery, 8 volts across red-green. Green-blue must be the rest of those 14 or 6 more volts. But my thought was, well, we could do the same thing just to practice it one time. Here's a 3 ohm resistance that has 2 amps going through it. Current times resistance should give you 6 volts right there. The other thing I want to point out, when I have it in this format, now it just looks like one of those circuits that we did over a month ago. All right, one of the first ones that we did back when we had time to do lab work together. You've got a battery push and charge through 2 series resistors. Notice the picture is consistent. You've got 2 amps and 2 amps. The same current goes through resistors in series. Okay, now for our purposes on this problem, we still need to figure out what is the current through each resistor. Okay, here's the current through the resistance. Now we can uncover a few things and figure out the current through each individual resistor. Okay. So the thought process here now, we know the voltage across a resistance, okay, 8 volts, red-green, across 20 ohms, 8 volts across 5 ohms, voltage divided by resistance should give you current, okay. I got these currents over here to be 0.4 amps and 1.6 amps. All right, so it is going to split up, and notice that these still add up to 2 amps. We know 2 amps came out of the battery. Here's our 2 amps accounted for. All right, certainly less current is going to go through the stronger resistor. More current will go through the weaker resistor. And I did the same thing over here. Now we've got 6 volts across 4 ohms, 6 volts across 12 ohms. I got that this should be 1.5 amps. This should be 0.5 amps. Again, they add up to 2. All right, weaker resistor should have more current. All right. So that's the thought process on this entire thing here. And I wanted to take that and now apply that to something else here. I'd like to apply it to what we're doing on UTexas. Let me change my share view here. The share view now, basically, I guess I'd like to give you the opportunity to take a picture of this or screenshot it or something, but here's a version of the UTexas assignment with my numbers on it, okay? If you try out my numbers, you should be able to find out the current from path A to C. If you look at my numbers here, you should be able to find out the current from path A to C. All right, each of those is basically asking you to go through the entire circuit process that we did, but the one answer you're going to fill in is how much of that current goes through this resistor from A to C. Here's an answer right here with my numbers. Okay, and then the same thing can be said, how much current goes through resistor that's in between A and C. All right, they show that right in here. And here's the answer they give you for that one. So 2 different circuits, 2 different scenarios, but hopefully the coloring that we did on this is gonna make that a little bit more reasonable to figure out on your own, okay? So give that a try when you get the opportunity. Again, please keep in mind that one is due Sunday night. You feel free to do this first to see if you're on the right track, or feel free to do your own first. And if you make a mistake the first or second time through, come on back to this picture and try this out with my numbers. All right, see what you can do there. So the last thing that I want to do here now is I'd like to take some time to go over this circuit. This is from your packet that we were working on. All right, this is page 11. This is really the culmination of all of circuitry. If we were in class, we would do some lab work after a few of these circuits. And it wouldn't have taken us this much time, but this is really tough to do all this stuff on your own. So I want to take it little bits at a time, and everything that we've done leads up to this toughest circuit. What I'd like you to try out on here is look at this piece here, figure out what its total resistance is. Look at this big piece here, find out its total resistance. All right, you need that so that you can get the total resistance of the whole circuit, because this chunk is in series with a 10 ohm resistor, which is in series with this big chunk, which is in series with a 20 ohm resistor. That's how we kind of interpret this this look. And now my thought is we can continue on with this by saying, let's suppose we replace those 2 resistors with a single equivalent resistor, just so we can figure out the red-orange color difference. Because we know that any current coming out of the battery will go from red wire to orange wire. Even though you and I both know it's going to split up, we can figure out that voltage difference from red to orange, knowing current through here, resistance here, we can figure out voltage here. All right, and I would say the same thing could be done right up here at this part of the circuit. Okay, we could figure out the total resistance here and see that you've got a yellow-purple voltage difference across this resistance. If we knew that total resistance, we know this voltage across here. I should grab a hold of this and drag it on over so you can see. If we know the voltage difference across here, then we're in business. We can figure out the current that goes through here. Or I'm sorry, we could figure out the voltage difference across here based on current going from yellow wire into purple wire, based on the total resistance that we know. Anyways, the other thing with this circuit, though, this is a little bit tricky because of what's underneath here. All right, what I just found is that yellow-purple voltage difference. That would apply to that resistor, but that yellow-purple is not going to apply to this or this resistor. What we'd have to do with this now is take a look and see that yellow-purple kind of is a combination of the both of them. Okay, and we did something like that last week also. But I could take and find that yellow-purple voltage difference and see that you've got 60 ohms of resistance sandwiched in between. 2 resistors in series, their combined resistance is 60. And we know the voltage from yellow to purple. We should be able to get the current that goes through that resistor right there. Okay, so that's the concept that we can go about with this. And there's a lot to it, I realize. But I'm hoping that these concepts here will sort of build up nicely to allow you to figure out the voltage differences that were given here. One more page that I want to share with you. This is something that is posted on Edmodo. All right, let me find that Word document. Right now we're looking at a PDF. Well, here's the Word document of the same thing. This is posted on Edmodo, and you may have seen it last week because it's on the same page as this. All right, last week, if you weren't here, I showed the order in which I went through this thought process. I did A, B, C, D, E, F, and once you've got one of these lettered boxes, then the unlettered ones kind of fall into place. All right. For example, you can take and drag this out of the way, and you can see the voltage here should be 12 volts. 12 volts, 14 ohms allows us to solve for current. We can solve for current and uncover that answer. Okay. Now, scroll down on this, and you're going to see this last circuit, this page 11 circuit, and everything that we just talked about should help you solve for this. And I've got some clues here that basically are what we just talked about out loud. But notice what I've got. Again, I've got A, B, C shown down in the totals row. I might want to do that first. I've got D labeled. I've got E labeled, F, G. In that order, that's kind of the thought process I went through on this, this circuit. And there's some tricky parts here. Up in this complex portion in the upper right-hand corner, that's going to take some time. That's going to take some thought. But again, hopefully these letters will get you going in the right order. Here's the other thing. If you're stuck here, like, wow, how do you do step F? Well, I've got a clue right underneath here. If I click on this, I can drag this out of the way, and it'll reveal a clue that will help you with that. I was hoping that would be helpful. I spent way too much time putting this together, but I like this stuff, and I want you to do well with it, okay? So just, there are plenty of strategies that are all consistent here, and you can use these clues to be helpful, okay? You might need to download this to your computer so that you can make edit marks on it, and then that way it doesn't mess with the original there. All right, but go ahead and use this, please, to help you out with that packet page. Again, I'm not collecting the packet pages. I'm just collecting UTexas. Please make sure you've got UTexas done by Sunday. And what I've got planned here, that's been about 40 minutes now because we started about 5 minutes late, is at this point, if you still want to, if you'd like to get together with somebody in a small group, I can do that. All right, I can get you connected in a small group, or you can stick around and ask me questions. If you're happy with what you've seen here and you feel like you can finish the packet with this assistance, if you can finish the UTexas with some of the other assistance that I've given you here, you're free to go, okay? No problem. It's not going to hurt my feelings. If you want to see more practice and you want to talk it over with somebody, stick around, and I'll keep this open for probably 10 more minutes, okay? So I'm going to stop share. And if you're sticking around, great. If not, we'll see you next week. Be on the lookout for an email come Friday, or excuse me, come Sunday, that kind of explains what's coming up next.